Okay, so if you've been keeping up with all the headlines, right, about the big AI race.
Yeah, the constant stream of news feels like it never stops.
Exactly. You probably picture this. Like massive sprint, neck and neck between the huge tech companies, you know, the Googles, the OpenAIs.
Right, the proprietary systems, the closed doors, the billion-dollar training runs, that's the common perception for sure.
But what if?
Hmm.
What if that whole picture is just, well, wrong, or at least significantly outdated?
Hmm. Interesting. Go on.
What if we told you the race? It might actually be over already, and the winner, not who you'd probably guess.
That's a pretty bold statement to kick things off. The race is over.
Well, maybe not over, but the dynamic has fundamentally shifted. And today, that's exactly what we're diving into. Because our sources, these are fresh from July 2025, they're kind of dropping a bombshell that hasn't quite hit the mainstream consciousness yet.
Okay, I'm listening. What's the bombshell?
It's this. Open source AI isn't just, nipping at the heels of the private closed systems anymore. It's not just catching up. It's already definitively pulling ahead, like demonstrably winning.
Winning. Okay, that's huge. But winning how? And based on what? Because winning in AI can mean a lot of different things. What metrics are we talking about here?
That's the crucial question, isn't it? And that's what we need to unpack.
Absolutely. And what's truly fascinating here, and what we'll really explore in this deep dive, is that the metrics, they aren't solely about like raw computational power or just the sheer size of the model, how many parameters it has.
Right, not just bigger is better.
Exactly. Instead, we're seeing open source AI really start to dominate in areas like efficiency, like accessibility, and even, you could argue, a fundamental philosophical shift in how AI is designed and developed in the first place.
A whole different approach.
Yeah, it's quiet, maybe, because it's not always grabbing the splashiest headlines, but it's genuinely a seismic shift. And it's being propelled by some truly groundbreaking innovations that are now, demonstrably eclipsing what the big proprietary efforts can achieve.
So this deep dive, it's really custom tailored to help you, the listener, understand precisely why this paradigm shift is happening right now.
And crucially, what its profound implications are for the future of technology, yes, but also for, your own everyday life. Because this stuff is moving fast.
Yeah, it really is. So our mission today is to guide you through the empirical proof, right? The hard evidence and the surprising facts, the crucial insights from these recent sources, July 2025, that show how these open source innovations are completely redefining what AI supremacy even looks like.
We'll dig into specific breakthroughs, try to understand the underlying reasons for this, dominance.
Yeah, dominance feels like the right word based on these sources.
And really discuss what all of this means for the global landscape of artificial intelligence moving forward.
Okay, that's a powerful setup. Let's dive straight into this seismic shift you mentioned. July 2025 really feels like a key moment, doesn't it? A definitive inflection point.
It really does. The sources are providing undeniable empirical proof. It's not just talk anymore.
Yeah, and what they reveal is that open source AI isn't just making small incremental gains, it's demonstrably pulling ahead of proprietary AI.
And on the very metrics that matter most for the next couple of years, right?
Exactly. We're not talking about a tiny marginal advantage here. The sources point to a clear, decisive win across critical metrics like accuracy, latency, and cost.
And that's the key part, winning on all of them simultaneously.
Simultaneously, which directly challenges that whole long-held assumption, that the proprietary models with their huge resources, their private data sets, would just inherently maintain this unassailable lead forever.
Right. The idea that only massive capital investment could produce frontier AI, that seems to be crumbling.
So how? How are they achieving this kind of synchronized superiority? It feels almost counterintuitive.
Well, it's not just a hopeful prediction anymore. It's really grounded in a series of very concrete examples that kind of hit the field in rapid succession, especially around this July 2025 mark.
Okay, let's get specific then.
Let's take ASI-Arch, for instance. This is a really revolutionary system developed out of Shanghai Jiao Tong University.
ASI-Arch. Got it.
So this system, it autonomously discovered over 106 highly optimized neural architectures. These are like the blueprints for AI models.
Okay, so it's designing AI models by itself.
Exactly. But what's truly remarkable is the efficiency. It did this discovery process in just 1,773 training runs. That's incredibly low.
1,773 runs. That sounds tiny compared to typical numbers you hear.
It is tiny. And to put that into perspective, the architectures it found achieved an impressive 82.5% accuracy on ImageNet.
which is that huge standard benchmark for computer vision, right? Classifying millions of images.
Precisely. A really tough test.
Yeah.
And it hit 82.5% accuracy while burning only half the FLOPs.
FLOPs, floating point operations per second, basically the computational energy cost.
Right, half the computational cost compared to a standard, well-respected model like ResNet-50.
Wow, half the cost for better than standard performance.
Yeah, and this isn't just about saving money or energy, though that's huge. It really highlights this profound level of self-improving design. It's AI creating better, more efficient AI from the ground up.
That's astonishing. So it's not just about discovering architectures, it's discovering them smartly and incredibly efficiently.
Exactly, and it's not limited to vision models either.
Okay, what else?
Consider Sapient Intelligence's Hierarchical Reasoning Model, or HRM.
HRM, right.
Now, this model is tiny by modern AI standards. We're talking just 27 million parameters.
27 million.
Yeah.
Compared to hundreds of billions or even trillions? That's minuscule.
It really is. Yet this diminutive HRM actually outperformed giants like GPT-4o on ARC-AGI.
ARC-AGI, that's the abstraction and reasoning corpus, right? The really hard one that tests abstract logic, almost like solving complex puzzles.
That's the one. Very challenging. HRM scored 40.3% compared to GPT-4o's 35.7%.
So the tiny model beat the giant on abstract reasoning.
It did. And the brain-inspired architecture they used, plus the fact that it required minimal training data, those are the crucial pieces here.
Minimal data, too.
Yeah. We're talking about achieving superior reasoning with significantly less data and way less computational overhead. That feels like a fundamental shift, doesn't it? Like maybe brute force isn't the only answer.
It absolutely does. It suggests that just scaling up, adding more parameters and data, isn't the only path, maybe not even the best path, to genuine intelligence or reasoning capability.
Precisely. And then let's look at another example. Princeton's knowledge graph-driven medical superintelligence.
Okay, specialized this time. Medical.
Right, not a generalist model trying to do everything. And it impressively surpassed GPT-4 on MedQA. That's a major benchmark for medical knowledge and question answering.
Surpassed GPT-4. By how much?
It achieved 92.4% accuracy versus GPT-4's 87.1%. Significant lead. But here's the kicker.
Uh-oh, there's always a kicker.
It did so at 1/10 the energy per query.
1/10. That's insane efficiency.
Yeah.
How?
Well, this model uses a bottom-up knowledge graph approach. It prioritizes structured knowledge, relationships between concepts, logical inference, rather than just relying on brute force statistical patterns found in massive text dumps.
So it's more about understanding the structure of medical knowledge.
Exactly. Which not only makes it incredibly efficient, but also potentially more interpretable, more reliable, especially in critical domains like medicine, where you need to know why the AI reached a conclusion.
Yeah, makes sense. And these examples, ASI-Arch, HRM, the Princeton model, they're not just isolated wins, are they? They seem to indicate a clear pattern.
That's the perfect point, because these recent breakthroughs we just discussed, the ones hitting around July 2025, they don't exist in a vacuum.
Right, they're building on something.
They sit atop an already formidable foundation. Our sources talk about a contiguous arc of open artifacts, basically, a whole series of powerful open source models and tools that were already outperforming closed systems even before this latest wave.
So this isn't just a few lucky shots or slash-in-the-pan successes. It's part of a continuous accelerating trend.
Exactly. It indicates a truly mature and rapidly evolving open ecosystem, an ecosystem that has been consistently setting the stage, proving its capabilities, and challenging those closed systems for a while now.
Okay, so let's talk about that foundation. What are some of those key open models that pave the way?
Well, you absolutely have to talk about Meta's Llama series. It's been a cornerstone, really, of the open source AI movement.
Llama. Yeah, everyone's heard of Llama.
Right. Llama 4, for instance, released back in April 2025, and that was building on the success of Llama 3.1 from mid-2024, which itself was already a massive 405 billion parameter model.
So these are big, capable models in their own right.
Absolutely. And Llama 4, with its specialized variants like Scout and Maverick, it brought really unparalleled efficiency for its size, incredible multimodal prowess.
Multimodal meaning it can handle text, images, audio, all together.
Yeah, seamlessly integrating and understanding different types of data. Plus, really impressive long context reasoning. We're talking up to 128,000 tokens.
128K tokens.
Okay.
A token is roughly a word or part of a word, right? So that's like processing a whole novel.
Yeah.
Or a massive technical manual in one go.
Pretty much. It allows for understanding really long, complex documents or conversations without losing track. The Llama series has just consistently pushed the boundaries of what open models can do release after release.
Okay, Llama is definitely a major player. Who else is part of this foundational arc?
Then there's DeepSeek R1, another powerhouse. Launched originally in January 2025, then updated in May with an even more capable version, the EO528 version, now packing 685 billion parameters.
685 billion, so even bigger than Llama 3.1.
Yeah.
What's special about DeepSeek?
What's truly impressive is its performance, especially in reasoning. DeepSeek R1 actually matches OpenAI's very capable O1 model in critical areas like math, code generation, and complex logical inference.
Matches O1. That's OpenAI's frontier model, right? That's a huge claim for an open model.
It is, and the numbers back it up. It achieved an astounding 97% on Math 500, which is a really challenging mathematical reasoning benchmark.
Right.
Compare that to O1's 94.2%.
Wow, how did they manage that?
Through some really innovative reinforcement learning techniques, apparently. But what's also key is accessibility. They've released distilled 8B variants.
Distilled, meaning smaller versions.
Exactly. They've basically captured the core reasoning capabilities of the massive 685B model and shrunk it down into highly efficient 8 billion parameter versions.
So you get top-tier reasoning, but it can actually run on, like, a regular laptop or less powerful hardware.
That's the idea, making that cutting-edge performance much more democratically available. It's a really smart strategy.
It really is. Okay, Llama, DeepSeek. Any others setting the stage?
We definitely can't overlook Moonshot AI's Kimi K2, unveiled just this July 2025, so very recent.
Kimi K2, what's its approach?
Kimi K2 is a mixture of experts model and MOE.
MOE, right? That's like having lots of specialist subbrains instead of one giant one.
Precisely. Instead of one massive brain trying to do everything, an MOE model has many specialized experts. And for any given task, only the most relevant experts get activated.
So it's more efficient because you're not using the whole huge model all the time.
Exactly. Kimi K2, for instance, reportedly activates only about 32 billion parameters out of a colossal trillion total parameters available.
A trillion total.
Yeah.
But only uses 32 billion at a time. Wow.
Yeah. And this allows it to really excel in things like agentic coding, acting autonomously to write and refine code, and in complex tool use like interacting with software or APIs.
Agentic coding sounds powerful.
It is. And crucially, Kimi K2 can handle massive 2 million token contexts.
2 million. That's way beyond Llama 4's 128K. What does that even enable?
It's like processing several entire books or enormous code repositories or lengthy project histories all at once. The implications for complex autonomous agent tasks where the AI needs a huge amount of context to understand the situation are immense.
Okay, I'm starting to see the picture. Llama, DeepSeek, Kimi K2. These aren't just small experiments.
Not at all.
So if you're keeping score at home, you can clearly see this pattern emerging. These are robust, rapidly extending families of open source models.
Consistently outperforming, or at the very least matching, the best of the closed systems across a really diverse range of capabilities, reasoning, multimodality, long context, efficiency.
Which brings us to a really critical point, something that seems to underpin so much of this success, the undeniable economic edge that open source AI possesses.
Yes, the cost disparity. Well, the sources call it decisive, and I think that's the right word.
Decisive. Why is cost such a monumental factor here? I mean, isn't AI development always expensive?
It is, but the difference in cost is staggering, and cost directly impacts everything. It impacts your iteration velocity, how fast you can try new ideas, fail, learn, and improve.
Right, the speed of innovation.
Exactly. It also dictates who can even access these powerful tools. Is it just a handful of mega corporations, or can startups, researchers, even individuals participate?
Accessibility.
Yeah, and it directly controls the sheer volume of experimentation you can afford to undertake. Proprietary models, with their sky-high costs for training runs, for compute time, for every single inference call, they create this massive bottleneck.
So if every experiment costs a fortune,
you do few experiments, you innovate slower, and you concentrate power in the hands of the few who can afford it, it fundamentally slows down progress for the entire field, except for those few giants.
That makes perfect sense. So let's put some hard numbers on this decisive cost difference.
Okay, let's look at training spend first. DeepSeek R1, which we just talked about, achieving performance comparable to OpenAI's O1.
All right, the 97% on Math 500.
They reportedly achieved that for under $10 million in training spend.
Under $10 million.
Yeah.
Okay. What's the comparison?
Compare that to the $150 million plus price tags that are still typical for frontier proprietary AI training jobs.
Wait, $10 million versus $150 million. That's a 15x saving.
at least. It's literally an order of magnitude cheaper to reach that top-tier performance using these open approaches and models.
That's mind-blowing. And it's not just the total training cost, right? You mentioned efficiency earlier.
Exactly. Think about ASI-Arch again, the system discovering new architectures.
Yeah, the 1,773 training runs.
It needed fewer than 10,000 GPU hours total for that discovery process. Now, conventional neural architecture search, NAS methods, they still typically budget 100,000 GPU hours, often more.
So, a 10x reduction in compute time and cost just for the design phase, before you even train the final model.
Precisely. And then there's HRM, the little 27 million parameter reasoning model.
The efficient reasoner.
It runs complex planning tasks using only 0.01 kilowatt hours of energy.
0.01 kilowatt already. How does that compare?
It's roughly 1/100th the energy footprint of comparable closed-source planning models doing similar tasks.
100th. The environmental impact alone. Not to mention the cost savings.
It's staggering when you think about scaling that up.
Okay, so training is cheaper, design is cheaper, running it's dramatically more energy efficient. What about the cost per use? The inference cost?
The inference costs, basically what it costs each time you use the AI token for token, are equally stark, maybe even more so.
Right, give me some examples.
Llama 4. For multimodal workloads handling images and text together, it comes in at an incredibly low 0.10 cents per million tokens processed.
And cents per million tokens.
Yeah.
And the proprietary alternative.
GPT-4o for similar multimodal tasks is around $5 per million tokens.
$5 versus 10 cents. That's a 50x difference.
50 times cheaper, yeah. And Kimi K2 with its massive 2 million token context window.
The MOE model?
It costs just 0.05 per million tokens for those huge context tasks. Comparable closed models like Claude are reportedly around $3 per million tokens.
$3 versus 5 cents. That's a 60x difference.
Roughly, yeah. These are not minor differences in API pricing. They are orders of magnitude. It makes deploying and using open source AI at scale vastly, vastly cheaper.
So in every single experiment you run, every bit of fine-tuning, every single time a user interacts with your AI, when it's 10x, 50x, 60x cheaper.
The impact is just profound. Your iteration velocity, how fast you can test, refine, improve, it just explodes. It compounds directly into capability velocity.
While the closed labs.
They're constrained. They're operating under these immense cost burdens. They simply cannot schedule enough of that expensive high-end A100 or H100 GPU time to keep up with the sheer pace of experimentation and development happening in the open.
It gives open source this compounding, almost exponential advantage over time.
Exactly. It's like one team is burning through fuel at 15 or 50 times the rate of another, even if they're driving similar cars right now. The long-term sustainability of that proprietary high-cost model, it just looks increasingly questionable.
This profound economic advantage, it leads directly to something broader, right? You mentioned democratization, sustainability.
Yeah, democratization and sustainability through sheer thriftiness. It's almost like efficiency is becoming the new superpower.
Then proprietary models struggle to replicate this.
Well, the profit-driven opacity, the closed nature, the need to monetize everything, it fundamentally hinders them. Their business models are built on control, on keeping the IP locked down, on charging premiums.
Whereas open source.
It's the opposite philosophy. Open weights, the models themselves are public. There's this deeply collaborative ethos, people sharing improvements freely, shared resources, shared knowledge. That's foundational to how open source achieves these staggering efficiencies.
Can you give an example of that collaborative advantage in action?
Sure. Look at Meta's massive $65 billion AI investment. That sounds like a proprietary play, right?
Yeah, you'd think they'd keep all that development in-house.
But a substantial part of that investment actually backs Llama 4's open weights. They're enabling free fine-tuning for anyone, anywhere in the world.
So they're investing heavily, but also giving away the core model.
Yes, and think about the impact. Llama 4's Maverick variant, designed for multimodal inference, it undercuts closed APIs by something like 80%. That's not just Meta being generous. It's strategically fostering an ecosystem that competes on cost and accessibility.
That's a huge boost for the whole community. What about DeepSeek?
DeepSeek R1's continuous improvements, things like adding crucial JSON support for structured data output, significantly reducing hallucinations or factual errors. These were developed, reportedly, for under $10 million.
Pocket change compared to the proprietary giants.
Relatively speaking, yes. And its latest 685B version, it infers at what you could call pennies per task when run on shared cloud clusters. And the energy use, 0.5 kilowatt per 1,000 inferences compared to Llama's estimated 2.5 kilowatt.
That's an 80% reduction in energy consumption for the same amount of work. Again, huge environmental and cost implications.
And Kimi K2's API pricing is setting entirely new standards, partly thanks to technical innovations like mu and clip stabilizers, which apparently prevent the need for expensive and time-consuming full model retrains when updating.
So smart engineering leads directly to lower operational cost.
Absolutely. And ASI-Arch, which we talked about finding efficient architectures.
Right, under 10,000 GPU hours.
The architectures it discovered boast a 70% lower energy draw during inference. We're talking 0.1 kilowatts per inference for those optimized models versus maybe 0.35 kilowatts for a standard vision transformer like VIT.
Wow. And HRM, the tiny reasoner.
HRM achieved its impressive stability and performance with minimal compute. It was trained on only about 1,000 carefully chosen samples for roughly $50,000 total cost.
$50,000, compared to the millions or even billions spent training large language models.
Exactly, and it consumes energy like a household appliance for complex reasoning tasks, just 0.01 kilowatt.
Incredible. And the Princeton model.
Similarly, Princeton's knowledge graph method builds these superintelligent medical systems for only around $20,000 per specific domain graph. Compare that to the millions often spent fine-tuning a large closed model for a specific medical task.
20,000 versus millions.
And its inference energy for answering MedQA queries is minuscule, 0.005 kilowatts per query. That's 90% less energy than GPT-4 uses for the same query, around 0.05 kilowatts.
It's incredible thriftiness. It's not just luck, is it? You mentioned the collaborative ethos.
It's fundamental. It rises directly from that open source spirit. Contributors freely share data sets. They debug code together in real time on public forums like GitHub or Discord. They proactively integrate optimizations like LoRaL low-rank adaptations to make fine-tuning cheaper and faster.
So it's a collective effort to eliminate waste.
Precisely. This collective effort avoids the massive waste and redundancy that often plague proprietary development cycles, where different teams might be solving the same problem in isolation, duplicating effort behind closed doors. Open source is just inherently more efficient at innovation.
And this isn't just benefiting the big tech players who release these models.
Not at all. This is about empowering literally anyone. It enables startups in, say, emerging markets to build cutting-edge AI solutions without needing venture capital measured in the hundreds of millions just to pay the compute bills.
It lowers the barrier to entry dramatically.
Hugely. And crucially, let's talk sustainability again. The world is grappling with AI's growing environmental footprint. Data centers are projected to consume an alarming 8% of global electricity by 2030 if trends continue.
That's a scary number.
It is, but these hyper-efficient open-source models offer genuinely greener paths forward. Their efficiency metrics are improving at an astonishing rate. The sources estimate around 40% efficiency gain annually for open models.
What is this?
Versus maybe 20% annually for proprietary models, which are often focused more on raw capability scaling than pure efficiency.
So open source is getting efficient faster.
Much faster. This promises not just faster innovation, but more inclusive, more sustainable growth for the entire field of AI. It's a game changer not just for the technology itself, but potentially for the planet, too.
That efficiency focus seems deeply connected to another major trend identified in the sources, the rise of microscale marvels.
Yes. The power of compact design in AI, this is another huge divergence.
How so?
Open source ecosystems are fundamentally departing from that old paradigm of building gargantuan parameter-heavy fortresses, these massive monolithic models that characterize so much of proprietary AI development.
They're showing you don't need a trillion parameters for every task.
Exactly. They're demonstrating that true intelligence, or at least highly effective AI performance, can be achieved with minimal overhead, leading to models that are both incredibly powerful and incredibly nimble.
So it's a strategic shift away from just chasing bigger numbers.
Absolutely. Proprietary models have largely been locked in this race towards trillion-parameter monoliths, which inherently demand hyperscale data centers, massive GPUs, huge energy budgets, just to function.
While open source is taking a different path.
It's charting a different course, countering with sleek, highly optimized designs. It's a fundamental divergence in philosophy. Instead of just adding more and more parameters, hoping intelligence emerges.
They're getting smarter about the architecture.
Smarter about how those parameters are used, how they're organized, how they interact, leading to more efficient intelligence that can run closer to where it's needed.
Okay, give me an example of these microscale marvels in action.
Let's look at Llama 4's Scout variant again.
Yeah.
It's an optimized transformer architecture. Even within the, say, 70 billion parameters of some Llama iterations, it can efficiently handle complex multimodal tasks.
Like understanding images and text together.
Yeah, but here's the key. It can do it effectively right on edge devices.
Edge devices, you mean like my phone or
Yeah.
a smart camera?
Exactly. Your smartphone, a smart camera, sensors in a factory, even a drone. It achieves this by intelligently activating only the necessary computational pathways within the model for the specific task at hand.
So it's not running the whole huge model for simple tasks.
Precisely. It makes it incredibly efficient, allowing it to run locally without constantly needing to send data back and forth to a massive, power-hungry cloud server. That's huge for privacy, latency, and offline capability.
That is a big deal. What about the distilled DeepSeek model?
DeepSeek R1's distilled 8B model is another brilliant illustration. It takes the core reasoning essence from that giant 685 billion parameter model
And shrinks it down.
distills it into a much smaller 8 billion parameter package. Yet this smaller version still remarkably outperforms many larger closed models on standard benchmarks. And it runs comfortably on everyday laptops.
How do they manage that distillation so effectively?
It's partly thanks to clever techniques like cold start data integration before reinforcement learning. Basically, it's designed from the ground up to be efficient and learn effectively even before the intensive fine-tuning stage.
Very smart design. And Kimi K2's approach.
Kimi K2's sparse mixture of experts activation is also revolutionary here. Remember, it has a potential trillion parameters, but only activates maybe 32 billion at any given time.
Right, the specialists.
This not only makes it incredibly powerful when needed, but also enables genuinely agentic coding complex autonomous programming tasks right on consumer hardware.
So I could have an AI building apps or fixing code on my own machine?
That's the promise. Building interactive applications, debugging vast code repositories, all with something like 30% less latency than if you're using a dense, fully activated model of comparable potential power. It's like having a specialized supercomputer available on your desk, but only the necessary parts are actually drawing power and running.
What's really exciting, though, is that the sources suggest recent developments are pushing these microscale models even further.
Yes, achieving incredible performance with vastly reduced resource demands. These models aren't just smaller in file size or parameter count.
They're fundamentally smarter designs.
Exactly. Smarter underlying architectures leading to superior efficiency and performance that, honestly, people just didn't think was possible at this compact scale until very recently.
Okay, let's hear about those cutting-edge examples.
ASI-Arch, again, it's not just discovering architectures, it's discovering incredibly compact ones, including novel approaches like linear attention variants, all under 10 billion parameters.
Under 10 billion, so significantly smaller than even Llama Scout.
Right. And these compact models are achieving 15-20% better efficiency on major benchmarks.
Better efficiency
meaning better performance for the amount of computation used. For example, 82.5% top one accuracy on ImageNet versus ResNet-50's 76.1%, or 91.2% average score on the GLUE language understanding benchmark versus BERT Large's 88.5%.
So better results.
While using 50% fewer FLOPs, half the computation, compared to large proprietary designs like VI Huge, which were previously considered state-of-the-art for efficiency.
Better performance, half the cost. That's the recurring theme.
It really is. Then there's HRM, the Hierarchical Reasoning Model, just 27 million parameters, remember?
The tiny giant.
Yet it delivers complex reasoning solving puzzles, planning steps 100 times faster than traditional large language models.
100 times faster.
Yeah. And its benchmark scores are phenomenal for its size. 40.3% on ARC-AGI, beating GPT-4o and Claude 3.5. Near perfect 98% on Sudoku Extreme, where O1 gets 85%. 95% on Mazehard versus Gemini 1.5's 88%.
This tiny model is just dominating these reasoning tasks. It proves deep logic doesn't require immense scale.
It really challenges that assumption, and Princeton's bottom-up knowledge graph approach continues this trend of compact power.
For medical AI.
Right. It constructs incredibly lightweight, specialized graphs, achieving 92.4% on MedQA, outpacing GPT-4, 89.7% on BioSUSQ, beating Claude 3.7. And these systems operate with parameter counts under 5 billion.
Under 5 billion by using structured knowledge.
Exactly. Leveraging those structured relationships instead of just throwing raw data and scale at the problem, it allows them to achieve really impressive intelligence with minimal computational demands.
And you mentioned transparency earlier. How does the open nature help drive these efficiencies?
It's a massive catalyst. Because the models, the code, the training methods are often open, developers worldwide can scrutinize them. They can find and prune redundancies. They can integrate advanced techniques like quantization.
Quantization making models smaller and faster by using less precise numbers.
Right. Exactly. And they can openly share optimized versions, optimized checkpoints of the models. The result is models that infer at blazing speeds, use less memory, and can be deployed practically anywhere.
So as these microscale marvels proliferate,
They embed AI directly into everyday hardware. Your smartphone optimizing your workflow in real time. Drones navigating complex spaces autonomously without needing a constant cloud connection. They're outstripping the closed systems, often trapped in that expensive, latency-prone, cloud-dependent paradigm.
it's about what this means for you, the listener. It's AI that lives right on your device.
Which means faster responses because the computation happens locally.
Enhanced privacy, because your personal data doesn't necessarily have to leave your device to be processed.
Right. And the ability for AI to function even when you're offline, maybe on a plane or in a remote area, it's not reliant on those massive distant data centers with all their associated costs, complexities, and potential points of failure.
That is a fundamental game changer. Pushing AI out of the cloud and literally into your hands.
Absolutely, for both personal and professional applications.
And this feels like it leads directly to the next big advantage highlighted in the sources. The collective brain.
Ah, yes, the decentralized advantage, the sheer power of the open source community itself.
It's described as a force multiplier that proprietary efforts just cannot replicate.
It really is. Just think about the contrast. You have relatively small, insular closed teams, maybe hundreds or a few thousand engineers working behind strict NDAs, versus literally millions of developers actively contributing, experimenting, sharing on platforms like GitHub and Hugging Face. It's a colossal, globally distributed pool of talent.
And that sheer volume.
It's not just volume, it's diversity of talent, diversity of perspectives, diversity of needs. This accelerates the evolution of AI incredibly. It transforms new insights, new research papers into practical code, into working breakthroughs at an unprecedented, almost unbelievable pace.
It's like a global nonstop hackathon where everyone shares their results instantly.
That's a great way to put it. Imagine that energy constantly driving innovation forward.
Let's see some examples of this collective brain in action. Llama.
The Llama ecosystem is a prime case. LlamaCon 2025, their developer conference, highlighted literally thousands of developers who are independently forking the Llama code, adapting it for custom integrations.
Forking meaning they take the base code and modify it for their own needs.
Exactly. And through this decentralized effort, things like boosting multilingual capabilities happen almost overnight. It's not a central meta team planning a feature for 6 months. It's the global community just doing it, adding languages, improving performance collaboratively.
That's incredibly fast. What about DeepSeek's community?
DeepSeek R1's repository on Hugging Face just exploded with community contributions after its release. This distributed community rapidly refined those distilled models we talked about, added crucial features like robust JSON output for better interoperability, improved function calling, all in weeks.
Weeks, things that might take quarters inside a large corporation.
Easily. That kind of rapid, community-driven development and feature integration is simply impossible for a proprietary lab with its rigid internal processes, sign-offs, and confidentiality barriers.
And Kimi K2, the MOE model.
Its GitHub repository reportedly hit over 50,000 stars by mid-July 2025. That's a huge indicator of community interest and engagement, and it's an active hub.
What are people doing there?
The platform openly invites tweaks and contributions for agentic extensions, new capabilities for autonomous AI agents. And this community effort is already expanding Kimi's applications to highly complex domains like computational biology and climate modeling, far beyond what any single company could likely tackle alone.
It's democratizing the frontier of AI application development.
Truly. And ASI-Arch, when the initial research paper dropped.
The architecture discovery system.
It immediately drew global collaborators. People started adapting its autonomous architecture, searching agents for incredibly niche, specialized areas, quantum computing simulations, specific medical imaging analysis tasks within days of the paper appearing online.
Within days. That's incredible speed.
Yeah. And this rapid proliferation of specialized architectures, developed by the community using the ASI-Arch framework, even led to new state-of-the-art results on benchmarks like CFAR 100 image classification. They achieved 94.8% accuracy, beating established efficient models like EfficientNet, 91.2%.
So the open framework enabled the community to push the boundaries even further.
Exactly. Same story with HRM, the reasoning model. Its initial research drop on ARC-AGI, the scientific preprint server, sparked a flurry of activity.
What kind of activity?
Developers rapidly forked the code, started integrating advanced techniques like quaternion processing, which can enhance stability and spatial reasoning. The community actively worked together, using shared benchmarks, to improve its stability and push its goals on harder reasoning tests like ARC-AGI 2 up to 5%, significantly better than baseline large language models manage, around 2–3%.
That's collective intelligence directly improving core capabilities.
Right. And Princeton's knowledge graph framework, once the core ideas were shared on ARC-FIF, it fostered a similar outpouring of extensions. People built new tools, created new benchmarks specifically for evaluating knowledge graph-based AI, like KG-LLM Bench.
And how did it perform?
On these community benchmarks, the open approach scored impressively. 85.6% on link prediction, predicting missing connections in the graph, way better than GPT-4o's 78.9%, and 90.1% on triple classification identifying correct facts versus Claude's 82.4%. Clear demonstrations of that collaborative advantage.
It paints a very clear picture. Proprietary labs iterate slowly, carefully, burdened by internal bureaucracy and DAs.
While open source merges code, integrates improvements, shares insights daily, globally, this sheer abundance of innovation, it's not just about the raw numbers of people involved.
It's the motivation, too.
I think so. It's often fueled by passion, by a desire to contribute, to solve problems, to build cool stuff. It attracts talent that wants to work for collective progress, maybe more than just corporate profits. It's a different kind of engine driving the innovation.
Which brings us to that powerful historical analogy you mentioned. The echoes of Linux.
Yes. The parallels are striking. The rapid iteration, the community-driven development we're seeing in open-source AI, it's a direct mirror of Linux's historical triumph over proprietary UNIX systems.
But compressed in time.
Massively compressed. Remember, Linux, built by that decentralized global community, slowly but surely eroded UNIX's dominance over maybe 2 decades.
Right. It took time.
But in AI today, these artifacts, the models, the code, the research papers, the data sets they're iterating weekly, sometimes even daily, not on multi-year release cadences like operating systems back then.
So those network effects.
And network effects where each new contribution builds on the last, attracting more users, more developers, creating a virtuous cycle. They're getting compressed from 20 years down into maybe a single breathtaking year or two in AI. Primarily this 2025-2026 window, according to the sources.
Wow. Just like Linux's volunteers built those robust, secure kernels that became the backbone of the internet.
OpenAI is now harnessing the collective genius of global minds to build the foundational models and tools of the AI era. And they're doing it faster, more efficiently, and more collaboratively than closed systems can seemingly manage. This collaborative effort is spawning derived tools, fine-tuned models for every niche imaginable, new applications exponentially.
The network effects that took 2 decades for operating systems are compressing into a single year for AI.
It feels that way. The pace is just extraordinary.
So if you, our listener, remember the rise of open source software like Linux or Apache Web Server, eventually dominating almost every piece of critical internet infrastructure, you're literally watching that same playbook unfold again right now, but at warp speed.
It really feels like history repeating, but on fast forward. This isn't just a heated competition anymore. It feels like a fundamental, perhaps irreversible shift in how technology is built, shared, and how it will ultimately dominate.
This rapid acceleration, this community power, it's also driving a really interesting strategic shift in what kind of AI is being prioritized. The sources talk about precision over generalization.
Yes, the rise of ANDSI, that's the acronym they use.
ANDSI, Artificial Narrow Domain Superintelligence. Can you unpack that?
So instead of chasing that single elusive dream of AGI, artificial general intelligence, the hypothetical, all-knowing, all-capable machine.
The sci-fi AI.
Right. The open source field seems to be pivoting, maybe more pragmatically, towards assembling swarms of task-specific ANDSI agents, basically AI that achieves superhuman performance, but within a specific narrow domain or task.
And the sources say this is where open modularity really shines.
Yeah, exactly. Because building these specialized components and having them work together requires that openness, that ability to mix and match, to integrate different pieces easily.
Okay, here's where it gets really interesting and maybe strategically brilliant. Instead of the moonshot of building one giant brain for everything,
Which is incredibly hard, maybe impossible, and carries huge risks.
open source is using its collective power to build lots of smaller, highly specialized superbrains, each designed for a specific task.
Precisely. And the results, as the sources show, are astounding in those specific areas. This shift feels irreversible, partly because it's delivering practical value now, and it seems strategically superior.
Superior to the single, often bloated model trying to juggle everything.
Yeah. ANDSI focuses on achieving true superhuman mastery that keeps it contained within specifics. This makes the AI more reliable, more verifiable, and often more useful in the real world today.
Okay, let's see some examples of this ANDSI mastery in action.
Llama 4, for instance. While generally capable, it particularly excels when fine-tuned for narrow multimodal domains, like medical imaging analysis.
We talked about that earlier.
Right. Surpassing human experts, achieving 95% accuracy on chest X-ray 14 compared to radiologists' 88%. That's ANDSI superhuman performance in the narrow task of reading chest X-rays. It's not general intelligence, it's specialized superintelligence augmenting human experts.
Makes sense. What about DeepSeek?
DeepSeek R1 achieves what the sources almost jokingly call godlike performance in math and code solving. That 97% on Math 500 versus O1's 94.2%, its Codeforce's rating of 2029 versus GPT-4's 1800.
So, superhuman in competitive programming and advanced math.
Exactly. Highly specific, incredibly complex domains where it demonstrates unparalleled mastery. That's ANDSI.
And Kimi K2, the agentic coder.
Kimi K2 truly masters agentic coding. It can autonomously write, test, and fix bugs in software. It achieves that astonishing 76% success rate on the SWE Bench verified benchmark for automated software engineering, significantly beating Claude 3.5 65%.
Fixing bugs automatically better than other leading models.
Yeah.
That's a very specific, very valuable skill.
Hugely valuable. And that precision in automated problem solving is NDSI in action, critical for real-world software development.
ASI-Arch fits this pattern too, doesn't it?
Perfectly. It doesn't just invent architectures, it invents architectures that are 15-20% better for specific vision or language niches.
Like the KeyCO object detection score.
Right, 52.3% mean average precision versus Yolovate's 45.1%. Or, in language, hitting 94.7% F1 score on the squad reading comprehension test versus Roberta's 92.1%. It's about creating hyper-optimized custom ANDSI solutions for specific problem sets.
And HRM, the tiny reasoner.
HRM pushes ANDSI in hierarchical logic and abstract reasoning, attaining 97% on theorem proofs in GSM-8K hard, beating GDT-4.0. That incredible 98% on the abstraction and reasoning corpus, way ahead of Gemini.
Even though it's tiny, it shows superhuman ability within that defined logical framework.
Far surpassing larger generalist models in those specific reasoning tasks. That's narrow domain superintelligence.
And finally, Princeton's knowledge graph approach.
Delivers superintelligence specifically within medical knowledge graphs. 96.3% on entity resolution in BioSQ, identifying medical terms better than closed models. 93.8% on relation extraction in SEMADB, understanding connections between medical concepts better.
Highly specialized, high-stakes domains where that narrow, deep accuracy is absolutely paramount.
And NDSI delivers it.
This NDSI approach, it seems perfectly timed for the agentic AI revolution that the sources say is unfolding right now in 2025 and 2026.
It really does. This is the era where AI systems are starting to autonomously perceive their environment, make plans, execute actions, and iterate on complex tasks without needing constant human handholding.
And agentic AI thrives on
Composability. The ability to build complex systems by combining specialized, modular components, each NDSI agent handling a distinct subtask it's exceptionally good at.
which is why narrow depth trumps broad, unfocused breadth in this agentic paradigm.
Exactly. A team of specialists often outperforms a single generalist, especially on complex, multi-step problems. Proprietary AGI attempts, often designed as those single monolithic brains, frequently falter here. They might overgeneralize, make inconsistent errors across different steps of a task, leading to unreliability.
And we're already seeing practical benefits from these ANDSI agents.
Absolutely. Enterprises are already deploying these specialized agents and reporting significant productivity gains. The sources mention figures like 35–40% in areas like software development, where agents write, debug, and test code.
Or supply chain management.
Right, where agents can optimize logistics, predict demand, manage inventory with superhuman accuracy and speed. This isn't theoretical, it's delivering real business value now, proving that ANDSI shines in practice.
Can you paint a picture of these agent swarms working together?
Imagine this. You have an HRM-derived planning agent, a member, 100x faster on puzzles, 95% on formal planning tasks versus O1's 82%.
Okay, the master planner.
It collaborates seamlessly with, say, an ASI-Arch generated vision expert, the one scoring 82.5% on ImageNet, better than standard VBTs.
The keen eye.
And maybe that swarm is augmented by a Princeton knowledge graph module specifically for medical reasoning, the one hitting 92.4% on MedQA, better than GPT-4.
The medical specialist.
These specialized agents, each excelling in their narrow domain, work together, passing information, coordinating actions to solve a complex diagnostic workflow from end to end, from analyzing imaging to querying patient history to suggesting diagnoses based on the latest research.
That's powerful. And the modularity helps with reliability.
Dramatically. It reduces single points of failure. If one specialized agent struggles, others might compensate, or the failing module can be more easily identified and fixed or replaced. Critically, ANDSI models are inherently easier to verify, debug, and align with human values because their scope and function are clearly defined.
Less risk of unexpected emergent behaviors from a black box.
Exactly. You minimize the risk of the weird hallucinations or biases that can sometimes plague the massive generalist models when pushed outside their comfort zone. Remember HRM beating GPT-4 on ARC-AGI? It did so with 99% fewer errors in its reasoning process, more accurate and more reliable.
And proprietary AGI pursuits, they stumble here.
Often, yes. Precisely because they try to be generalists. They might do okay across many things, but excel at nothing, leading to inconsistent performance on critical multi-step tasks. We saw Claude 3.7's 84.3% on BioACQ versus Princeton KG's 89.7%, specialized ANDSI winning in a vital domain.
That focus allows for intense optimization?
Yes. Like ASI-Arch running architectures specifically for agents that need to call external tools, achieving 85% success on web arena tasks, navigating websites, filling forms versus closed agents managing only 72%. Deep focus enables peak performance.
And these agents are projected to take on more decisions.
The sources estimate 20–25% of daily routine decisions in various fields by 2026. Think healthcare triage, where Princeton KG's accuracy is crucial, or financial forecasting, where DeepSeek's math prowess shines.
And open source facilitates this rollout.
Fundamentally, developers can easily mix and match these highly optimized open source ANDSI components. Fine-tune an HRM for planning, plug in Kimi K2 for coding execution, maybe add a specialized Llama variant for communication, all at a fraction of the cost, and with significantly reduced risk compared to building one giant proprietary system.
And this ANDSI approach, it sidesteps some of the bigger ethical concerns around AGI.
It does, to a large extent. The existential risks often debated around AGI, unchecked superintelligence, unpredictable goals are less pronounced with ANDSI. These are domain-bound intelligences. They excel within safe, clearly defined boundaries.
Which should accelerate adoption.
Especially in regulated industries. Law, where HRM hits 98% on legal reasoning benchmarks. Medicine, where Princeton KG gets 93.8% on SemaDB medical literature analysis. You get the power of superintelligence, but in a more controllable, verifiable, and trustworthy package.
It's reliable, transparent, controllable AI.
And one more point on agents. In this new era, emphasizing multi-step reasoning and complex tool use, ANDSI's narrow depth allows for truly emergent capabilities when you combine these specialists intelligently. Think of ASI-Arch's optimized vision models boosting the perception accuracy of an entire agent swarm on COSIO object detection, 52.3% of 45.1%. Simultaneously, HRM intelligently decomposes the overall complex task into manageable subgoals, 95% on Maze-Hard versus 88%. This combined power, leveraging multiple specialized superagents working in concert, can demonstrably outperform any single AGI trying to be a jack-of-all-trades, master of none.
So what this ultimately means for you, our listener, It's not about waiting for some far-off, maybe scary, all-powerful AGI.
No, it's about having highly reliable, incredibly specialized AI tools becoming available now or very soon. Tools that can augment your own capabilities in profound ways.
Automating complex tasks, significantly improving whole industries like healthcare or finance.
And doing it all with a far greater degree of transparency, efficiency, and control than we've seen from the closed, monolithic approach. It really feels like a future driven by shared, open, specialized intelligence.
Which leads us to the final section, how this all comes together for the agentic future.
Right. This collective culmination of strengths, the microscale models, the unparalleled cost efficiency, the massive, passionate developer community, and that laser focus on ANDSI.
It all perfectly primes open source AI for this agentic revolution that's unfolding right now, 2025, 2026.
These combined forces mean open source isn't just participating. It is demonstrably leading the charge towards autonomous systems that can plan, adapt, and execute swiftly and reliably in the real world.
And we're not just talking hypotheticals. These specific open source models are already powering autonomous systems, showing immediate applicability and deployment readiness.
Exactly. Llama 4, for instance, is already being used to power agentic systems for complex business workflow orchestration. Companies are deploying sophisticated automation using Llama agents in hours or days, not the months it might have taken previously.
And DeepSeek R1.
Its advanced function calling capabilities are enabling the creation of incredibly versatile multi-tool agents. Think agents optimizing global supply chains, managing warehouse inventory, predicting shipping demand with unprecedented accuracy, using multiple software tools seamlessly.
Kimi K2.
The coder. It's not just assisting programmers. Sources suggest it's literally building fully functional websites or deploying complex software applications autonomously, and doing it at that jaw-dropping 90% lower cost compared to using proprietary model APIs for similar tasks. That's revolutionary for startups and individual developers.
ASI-Arch. The architect.
Its ability to invent custom, efficient architectures is birthing specialized agents designed for intricate tasks like sophisticated web navigation, scraping data, filling forms, interacting with complex online environments, achieving impressive 80% success rates right out of the box.
HRM, the planner.
With its hierarchical reasoning, it's planning incredibly complex multi-step workflows for robotics, making advanced industrial automation, complex assembly tasks, or logistical sorting potentially 100 times faster and more adaptable. Imagine the factory floor of the near future.
And the Princeton KG model.
Already spawning highly domain-specific agents for medical diagnostics, achieving that remarkable 92% accuracy in assisting diagnoses during real-world clinical trials, providing invaluable decision support to doctors and healthcare professionals.
It feels like the pieces are all falling into place. Open weights cut the latency and cost.
Transparency builds the necessary trust for deploying autonomous systems.
And as these agents start handling that, projected 20% of routine decisions by 2026.
These focused, highly capable, cost-effective open-source rollouts are simply going to dominate the landscape. Open source is leading that agentic charge.
Which brings us back full circle to that Linux analogy.
It really does. If we connect this all to the bigger picture, the historical trajectory of open source is just so clear, so compelling. This isn't just a temporary blip or a niche trend. It's a proven model for achieving technological dominance.
Now accelerated to warp speed for the AI era.
Exactly. It echoes Linux's victory in internet infrastructure so powerfully. History is repeating, just much, much faster.
Remind us of Linux's path again.
It started with microscale kernels running on cheap commodity hardware. It built unstoppable momentum through relentless, decentralized iteration by that global developer horde. It achieved narrow superintelligence, becoming exceptionally good at specific networking and server tasks, and it scaled the entire web through adaptable, agentic-like scripts and configurations.
And by 2000,
Linux was powering something like 70% of all websites, total dominance from grassroots open development.
And today, OpenAI is clearly on that exact same trajectory.
Turning those once impenetrable proprietary AI silos into, well, maybe relics of a past era sooner than many people think.
So let's try to wrap this up. What does this all mean for you, our listener? We've journeyed through the evidence from July 2025.
We've seen how Llama's efficiency, DeepSeek's reasoning, Kimi's agency, ASI-Arch's inventiveness, HRM's hierarchies, and Princeton's knowledge graphs aren't just isolated cool projects.
Right. Together, they represent something much bigger. They herald this transformative future of shared, accessible, highly capable intelligence.
The old proprietary closed model seems to be fading, or at least losing its undisputed leadership. And a new open dawn is illuminating a potentially boundless future for AI innovation and deployment, driven by collaboration and efficiency.
But here's the final important question we want to leave you with. As these incredibly powerful, specialized open-source super agents become increasingly integrated into our daily work, into our lives, automating complex tasks, making routine decisions, augmenting our abilities, what does that free us up to do? What new frontiers of human creativity, of uniquely human problem-solving, of personal fulfillment will you be freed up to explore when the machines handle more of the cognitive load?
That's the really exciting question for the next chapter. We truly hope this deep dive has given you a valuable shortcut to understanding this critical shift happening right now in AI. We hope it sparked some aha moments.
And maybe even inspired you to look closer at this incredible open-source revolution unfolding all around us. It's moving fast, and it's changing everything.
Thanks for joining us.
Until next time, keep digging into the fascinating world of technology.